So let me show you what the whole course of events is going to be. Hold on. The course of events will be the operator will move this stick to the right or left. Okay, so the operator will decide whether he wants to go left or right, and this device sends a pulse width sends a radio signal to a receiver, which this will be, and the receiver will be an input to the Arduino. So when the operator moves the lever, the signal tells the Arduino that which way he moved it and how far he moved it, and in a sense how fast he moved it, but how far he moved it. So this device is to take that signal from the operator and turn it into a signal that has enough current to drive this electric motor. So that's what this does. So this is an amplifier, if you will. It's some transistors and some MOSFET, probably MOSFET transistors. This is the motor speed controller. This controls the current and the voltage going to this motor. So it can invert the voltage to invert the direction, and it can change the current or the voltage to the motor to change its speed. And that is based on the input from this. So operator moves the lever. This goes to the receiver on the machine. The receiver tells this what the operator wants to do. This tells this to turn the motor. When the motor turns, the potentiometer reads that motor has turned and goes back and tells this whether it's turned far enough. So if the operator moves this lever, to the full extent of it, then this would want to make sure that this turned to its full extent. So let me power this motor. I'm going to use this battery. I'm going to power the motor. Watch the voltage. So I'm just going to put it in different spots here. 3.1. Actually, I'm going to take it right to the very end. That's the end of what I would want this to go. If it went any farther, it would start doing damage, install the motor, and it just wouldn't be good for it. So that's 3.49, 3.5 volts coming out of the potentiometer at its fullest extreme. What I can do is I can use that number in the programming of this and say, never go past 3.4 or 3.3. If you ever go past 3.3, then stop. And what that'll do is it'll put an electronic limit on the position instead of a physical limit, which would be safer as long as nothing went wrong. So if I move to the very other extreme, there's 1.56 volts. And again, I could write the same code that says if you get below 1.7 volts or something, then don't go any farther. Only go the opposite direction. So that can all be built into code rather easily. So I'm going to do that. I would love to put mechanical limit switches on this. It's a bunch of engineering that I'm hoping I'm going to build lots of dead zone into the programming of this. I don't think I need nearly this much movement, so I can electronically shut it off very closely, and I'll just monitor it for a while and see if it works. And if it looks like it's going to be problematic, then I'll put mechanical limit switches on here, and just as a kind of a secondary precaution. So that's the steering system. I probably want to 3D print some sort of cover for this to keep it clean. I have to make a electrical harness for it. I want to bring 3 wires from here up the back of the motor and up with the power wires for this, and then run all of this back to one of those aluminum cases that we saw in the previous video, where all the controls, where all of this stuff is going to be up inside the some sort of control box or something. But I want to make this into a one sealed, finished, ready to install, bulletproof thing.